In this video, we continue with combat and explore both hitboxes and hurtboxes. Today, our goal is to be able to define, detect, and communicate the results of a hit. For example, during the specific frames of an animation, you may call your hitbox to search for hurtboxes, and if one is found and validated, you might want to play a sound, emit a particle, or remove some health. In this implementation, we won't rely on the physics events such as on-collision enter, stay, or exit, or the trigger versions of the events. This is to reduce the overhead that they can have and increase the flexibility of our use cases. Let's start with a diagram to get a high-level overview of what all this entails, and how it will work. We're going to be using interfaces to implement this. There are going to be 4 in total. If you're new to interfaces, they are a way of generically handling different classes without needing to inherit from a common ancestor. Anyway, there's a hit responder and a hurt responder. These represent who is doing the hitting and who is getting hit. The other 2 interfaces are the hit detector and the Hurtbox. It's between these two that a hit occurs. The hit responder will ask the hit detector to search for Hurtboxes, and if one is found, it will generate a hit data. After that data is validated, it is propagated back to both the hit and hurt responder. And from there, the responders, as their name implies, will do their response. In this scene, I'm going to replace the current target with a punching bag that we'll be using from now on. Using the combination of a collider, rigid body, and a character joint, we have something that acts like how a real punching bag might. This is what we're going to be punching. Next, let's create a new Hurtbox layer for our Hurtboxes to reside in, as we'll be using colliders to define their area. I'll create a new script for the hit data and the interfaces. Even though I'm going to be putting them all in the same file, you can separate them if it fits your style more. I'll declare hit data as a regular class that does not inherit from mono behavior, and the rest as interfaces. As the name suggests, hit data is the data you want included and sent to the responders, not unlike a raycast hit. This data will vary depending on your game and the type of responses you will have. For me, I'll include the damage, where the hit occurred, the normal of the hit surface, the Hurtbox hit, and the hit detector. The hit responder will define the damage dealt, a check hit function to validate the hit data, and a function to respond to the hit. The hit detector will define the hit responder they report back to, and a check hit function that is used to look for hurtboxes. Like the hit responder, the hurt responder will also have a function to validate hit data and a response. Lastly, the hurtbox will have a boolean to determine whether it's active or not, an owner, as entities may have multiple hurtboxes and the hurtboxes may not be on the root. The transform of the game object that the hurtbox is on, sometimes I find this useful, a hurt responder to report the hit to, and a check hit to validate the data. Returning to the hit data, we always want to validate in the same order for consistency, so let's make a new function called validate. If the hurtbox is not null, if the hurtbox check hit returns true, if the hurtbox's responder is either null or its check hit returns true, and if the hit detector's responder is either null or its check hit returns true. If all of that is true, then the hit data is valid, otherwise return false. Each of the check hits we send this, referring to the hit data itself, giving each one of them an opportunity to change the data. Even though it isn't passed by reference, changes inside the object will still carry over. All of this may be excessive if you only need a simple yes or no if a hit occurred, but it is flexible, so adapt for your situation. We've defined the interfaces, but by themselves they don't do anything. They need to be implemented by a class. For our hit detector, we're going to create a hitbox, and this is the area that we want our hitbox to check. In actuality, it's going to be this smaller box here, that's going to be swept in this direction to this endpoint. This is a box cast. We could use an overlap box, but a box cast gives us a hit normal that I usually find useful. Here, we have the center of the hitbox, the start or origin of the cast, the direction of the cast, the distance, and the thickness of the sweeping box. So we're going to use a box collider to define the area we want to check, but use a box cast to do the actual checking. Let's create a new C# script called Hitbox, and it will be a mono behavior and it will be implementing the hit detector interface. Then I'll declare two serialized variables, one for the box collider and the other for the layer mask. A private float for the thickness, arbitrarily instantiated to 0.025, and a hit responder to be the backing field of our property. CheckHit is the function that will search for Hurtboxes, and to start we'll instantiate a scaled size, which is the size of the box collider factored on each of its axes by the lossy scale of the game object. This is the size of the gizmo you see in the scene, and the area we want to sweep. Note, you cannot use transform.transform vector as it will treat it as a vector and not a set of dimensions, and will apply rotation as well as the scaling. Then we'll define the distance as the scaled size.y subtract thickness, direction as transform.up as we use the y in our distance calculation, center as a transform point of collider.center, the start point as the center moved in the negative direction by half the distance, half extents of the sweeping box as the scaled size, replacing the y with our thickness and dividing by 2, and the orientation as the transform's rotation. Next, we'll create an array of raycast hits to store all the hits returned by the physics.boxcastAll using the previous variables and the layer mask. You have to use boxcastAll here because, for example, if we swung a sword through two enemies, we need to register a hit for both of them, not just stopping at the first. Let's create a temporary hit data and a Hurtbox, then using a for each to iterate through all the raycast hits in the array. Hurtbox is equal to the hit.collider.get component of type iHurtbox. Make sure it's the collider and not the transform, as that can give you the transform of a parent game object that contains a rigid body. If it's both not null and active, we'll generate a hit data. Damage is either 0 or the damage of the hit responder. The hit point is either the center of the area or the raycast hit point if it doesn't equal vector 3.0. This is to accommodate for cases where the cast starts within a collider, as documented in the manual. The hit normal is the hit normal, the Hurtbox is the Hurtbox, and the hit detector is itself. If the hit data is valid, we'll call the responders responses if they aren't null. This is our hit detector, and now we have to make our Hurtbox. So a new script, comp Hurtbox, that inherits from mono behavior and implements the iHurtbox interface. Then I'll create backing fields for active, owner, and the hurt responder. Active returns active, owner returns owner, transform returns the transform, and hurt responder returns the hurt responder. In this example, we don't have any special checks, so the check hit can just return true, but I will add a debug log saying that the responder is null. It might save some headache later. And that's it for the Hurtbox. That's 2 parts of the equation down and 2 more to go. Next up is the hurt responder. Returning to our punching bag, let's go ahead and make a component for it. The punching bag will implement both the iTargetable and the iHurt responder. Like before, I'm going to make serialized backing fields for the iTargetable as well as a field for a rigid body that will come into play later. Additionally, we'll declare a list of Hurtboxes. In the start function, we'll populate the Hurtboxes with all the Hurtbox components in the game object and its children. We'll iterate through the list and assign the hurt responder as the punching bag itself. Our punching bag has no special validations, so the check hit will simply return true. And for now, I'll just have the response produce a debug log to show that it happened. Returning back to the scene, let's add the punching bag component to our punching bag, and we'll assign the bag to both the target transform and the rigid body. To set up the Hurtbox, I'll create a new empty on the bag as it needs to be on the Hurtbox layer. Add a capsule collider and a Hurtbox component, resizing the collider and setting it as a trigger so it doesn't collide, and set the owner to the root of the punching bag. Now we need to make the punching bag targetable. To do this, we need to add a collider to the root. And this is where we can kind of see the downsides of how we did target acquisition in the previous video. We have 3 colliders each for a different purpose. There's one on the root for targeting, one on the bag for collisions, and the third on the Hurtbox for hit detection. If we did acquiring a target differently, we could eliminate one of them. Entering play mode, the bag starts to freak out. That's because the collider on the root should be a trigger so it doesn't collide with the collider on the bag. And while we're at it, we should update the collision matrix in the project settings so the Hurtbox layer has no collisions. Alright, now we have a targetable, collidable bag that can receive hits, but we don't have a way yet, so that's the next step. The last part of the equation that we're missing is the hit responder. For this, I'm going to create a test script. It will implement the iHitResponder interface. And it will also have a bool called attack that controls when to call the hitbox's check hit, a backing field for the damage property, and a reference to the hitbox. Again, there are no special checks, so check hit returns true. In the start, we'll assign the hitbox's hit responder to this, and in the update, if the attack is true, we'll call the hitbox.checkHit. Lastly, there is no response. To test this, in the scene I'll add a cube, set its collider to trigger, add the test hit responder, add the hitbox component, referencing the collider as the collider that defines the area, set the layer mask to be only the Hurtboxes, and reference the hitbox in the hit responder. In play mode, we can drag the cube into the punching bag, and once the attack is set to true, we can see that a hit occurs and we get a hurt response. One last thing before we wrap up this video is that we want a way to differentiate between the player, enemies, and allies. One approach is to use extra layers, but that kind of clutters everything up, and you're limited in the number of layers you can have. Instead, we'll create our own quote-unquote layers, working very much like the Unity layers and layer masks, where an object can only be on a single layer and a layer mask can be a combination and is used to filter them. Alan Zacconi has a really good blog post about this topic, and I'll link it in the description if you want more information. How this is implemented is through the use of enums, one for the Hurtbox type and one for the Hurtbox mask, and I'll do this in the hit data script. For the Hurtbox type, I'll define player as 1 bit shifted left 0 times, enemy as 1 bit shifted left 1 time, and ally as 1 bit shifted left 2 times. We do this as it's very important that each enumeration has a value that is represented by a single set bit in binary. In base 10, these numbers are 1, 2, 4, 8, 16, and so on. For the Hurtbox mask, it needs to be marked with the system.flags attribute. In Unity, this allows you to select multiple values in the inspector. The Hurtbox mask needs to be the same as the Hurtbox type. However, it has an additional value of none at 0. Now the Hurtboxes need to have a Hurtbox type, and I'll update the Hurtbox component with a serialized variable to complete the implementation. This means the Hitbox implementations need to actually account for the Hurtbox type. In addition to the layer mask, I'll also add a Hurtbox mask, and before the hit data generation, we'll do our check. The Hurtbox is valid if the Hurtbox mask.has flag of the Hurtbox type is true. Here, you also need to cast the Hurtbox type into a Hurtbox mask or it'll throw an error. So, the Hitbox mask for enemies and the punching bag is also of type enemy. Setting attack to true, we get responses. However, if I change the bag to player, the responses stop. Changing the mask to both players and enemies, we get responses again. Now we have a way of differentiating Hurtboxes, and this is useful if you have teams. And that's all I had for today, but that doesn't mean you have to stop here. Some ideas that you guys can tackle to take this further and beyond is to create different hit detectors that use varying shapes or special validations, adding attributes to the hit and Hurtboxes in the style of Monster Hunter, where slicing can dismember and being heavily armored is deflecting, or elemental affinities and certain combinations having unique effects like in Magicka or Spellbreak. That's it, and I hope to see you in the next one, but bye for now.